Now let us perform the steady state operation, and with that reading we'll verify what actually we are getting from the VI characteristics which we got from this table. Once we plot it, then only we'll be able to get it, and then will record the steady state value with the maximum voltage, which is 230, as you can see here. This is denoted at V0 in the table 2 for the experiment. So we set it at 230 volt, and then we keep the rheostat in the mid position to have the 50% of the full value, so which will be approximately 100 ohm, because it is a 200 ohm resistor, variable resistor, so max it can reach from 0 to 200 ohm resistance. So when we keep at the 50% position, we get approximately 100 ohm here. Okay, so we'll verify that by recording the drop across the lamps. If you note the reading V2, so this reading is basically what 230 minus drop across the external resistance, then what is applicable over the two lamps which are connected in parallel. So this we can see it is supposed to be 155. Okay, so we have taken this reading which is 155, which is as per the table it will be V10. So this is the drop across your lamps. Then what is the drop across the rheostat? This is your rheostat. So this drop is 230 minus 155. So 230 minus 155, we'll write it here. This is your 230 volt input, 155 is the steady state voltage drop across the lamps, and this I10 and I20 is the steady state current through these two ammeter. So this is the ammeter for the tungsten lamp, so you can see it is 0.61. So we'll record this table parallelly will complete, which is 230, this is 155, and then we record I1 as 0.61, and this I2, which is for the carbon, it is 140 milliampere, so that indicates it is 0.14 ampere. So if we put it there, it is 0.61 plus 0.14. So if you complete this calculation, you will approximately get it as 100 ohm. So we have taken REXT, this is your REXT as 100 ohm, and we got this steady state value. Now let us do it again with the maximum external resistance. So we'll set it to 200. This is the maximum resistance, which is 200, and for that we just record the voltmeter reading. So voltmeter reading, if you would see here, this is 230 as usual, because we keep it its maximum value, and then drop across the lamps, it will be how much, it is 105 or 110, between that. So let us take 107 something, and then we record the reading across the this is for carbon filament lamp, so this has come as 110, so 0.11 ampere, and for the tungsten this is little less than point, so let us take 0.49. So this is all in ampere. So ampere, this is volt. So once you get this reading, then you can draw the load characteristics at I'll prepare the table characteristics, and then over that I'll overplot this load characteristics, then it will be clear. Then only we can complete the other part, which is the estimated value from the graph. So these two will get from the graph, and then we'll be able to cross check whether the VI characteristics, how much valid we got it, okay, from the plot, right? So with this, our experimental reading, everything is completed. Now we have to complete the drawing part, I mean the demonstration part of this table, so that we can get a VI characteristics for the tungsten and carbon lamp. So with this we conclude the experimental part.